We've seen now that as t changes, typically our ur and u theta vectors are going to change along with t. Let's ask what the rate of change of the r and theta vectors might be. So we take the time derivative or the t derivative of our ur and the t derivative of our u theta vectors. What do we get? Well, u sub r is I cosine theta plus j sine theta, u sub theta negative sine theta, I plus cosine theta j, and okay. So the derivative of ur with respect to t, I'm going to just use the prime now for the derivatives just to save a little bit of space. That's I cosine theta plus j sine theta. Now recall that theta stands for a function that's changing with t. This angle is changing in time, so I'm going to call this I cosine theta of t plus j sine theta of t, just to remind us that theta is a function of t, so that our derivative, being with respect to t, is going to be what? Well, it's going to be I times the, well, it's going to be negative I times the sine of theta of t times d theta dt plus j cosine of theta of t, again times d theta dt. I'm flipping in and out between prime and d dt notation, but using the chain rule, cosine of theta of t, inner function is theta, so that we have to take the derivative of that. That's where our d theta dt comes from, and the derivative of the cosine is the negative of the sine function. Okay, the derivative of u theta with respect to t is the derivative of negative I sine theta of t plus j cosine theta of t, and that's going to be negative I cosine theta of t d theta dt plus minus j sine theta d theta dt, and that's theta of t there. If we look at this closely, we see something kind of interesting, that the dur d theta, and this has gotten a little bit crowded here, and I apologize for that, but let's try to live with it. Okay, our dur dt has I component negative sine theta and j component plus cosine theta. Well, that's the same as u theta, so that we see that dur dt equals u theta times d theta dt. And similarly down here, this is negative cosine theta, negative I cosine theta minus j sine theta, which is just the negative of the I cosine theta plus j sine theta. And we can say that, if I can get it in here, du theta dt is, as a result, equal to negative u sub r times d theta dt. This tells us how our ur vector changes with respect to t and how our u theta vector changes with respect to t.